A ship of a displacement 10,010 ton has km 6.7 meters, gm 0.76 meters. A mass of 10 ton having kg 7.6 meter is shifted transversely. The deflection of a pendulum of length 7.6 meter is 0.125 meters. Find the distance through which the mass is shifted. Also find the position of the new center of gravity above the keel due to the removal of the same mass. This is our ship, let's say. The displacement has been given to us as 10,010 ton. Km, the height of metacenter above the keel, is 6.7 meters. Initial GM of the ship 0.76 meters. The mass is 10 ton and lying at a height of 7.6 meter above the keel. See, we have attached a pendulum to the underside of ship's deck. Let's say this is that pendulum shown to you. Here I have shown you the magnified version of the same. Okay, so let's say it is that pendulum which is going to be ideally here. Okay, hanging through underside of the deck. Now length of the pendulum is 7.6 meters and a deflection noticed at the base is 0.125. We have to be very clear about what exactly these two things refer to. Let us see. This is that mass 10 ton already being on the ship's upper deck or being anywhere in the ship. With that weight present onward, the center of gravity and center of buoyancy are initially being on the ship's center line and the ship is in its upright state. We are going to now shift the weight across the ship. You see here, a mass of 10 ton having kg 7.6 meters. Kg is the height above the keel, the vertical distance. And it is shifted transversely. That's what you noticed here. The weight has been shifted transversely. It will essentially cause the ship's center of gravity to move away from the center line. A gravitational weight through new center of buoyancy and the buoyant force through original center of buoyancy will be forming a couple movement, effect of which will be to cause the vessel's listing. That means this is listing movement. So the ship is going to incline. The pendulum will also incline within the vessel. Okay. And the ship will achieve a new equilibrium state. Got it up to here?
Yes, sir.
Okay. Yes. So here, small a is the deflection noticed at the base of the pendulum. Small l is the length of the pendulum. Okay.
Yes, sir.
So these two things, these two parameters will help us to determine tan theta. Okay. Where theta is the angle of list. So this data given about the pendulum will help us to know tan theta A upon L. A is given to us 0.125. Length is given to us 7.6 meters. Understood?
Yes, sir.
And you are aware of the formula about angle of list. Tan theta is given by m into d upon delta into gm. Correct? Where d is
Yes,
this transverse distance covered by the weight. This d distance, okay, you may also write it with the suffix small t, okay, dt. So that would be
dt.
the transverse distance covered by the weight. You might have noticed the weight was earlier here and it was
Yes, sir.
shifted across the ship. So this transverse distance covered will be d. Question is asking us to determine that distance only. Calculate the distance through which the mass is shifted. One more thing you may
Yes, sir.
one more thing you should understand. I am using weight and mass terms interchangeably. So don't get confused. Okay. Let us think both of them are being expressed in tons only. Okay.
Yes, sir.
Yes. Okay. So now tan theta we are having right from here. M is 10 ton. D is unknown. Delta is 10,010 ton. And GM is 0.76 meters. Can we solve it now for D for the purpose of having our answer?
Sure.
Very well. 12.512 meters will be the transverse distance covered by the weight. Okay. When the
Yes, sir.
deflection at the base will be noticed 0.125 and with a length of pendulum 7.6 meters.